Welcome back. Properties and laws of a logarithm. The first property, or this is actually a definition of logarithm. X is equal to logarithm of b raised to x with a base b. I wrote once again this one. The exponential function y is equal to b raised to x if and only if x is equal to logarithm of y with a base b. As you can see, my y is b raised to x. This one is b raised to x, so that means x is equal to logarithm of b raised to x with a base b. They are equal. These are equal. Okay? So that means this one is the same as this one. Okay. So for example, I'm going to use 3 raised to 27, I should say, is equal to 3 raised to 3. Yeah, 3 raised to 3. If and only if 3 is equal to logarithm of 27 with a base 3. Or we can say that 3 is equal to logarithm of 3 raised to 3 with a base 3. That's pretty obvious. Okay. For to understand the next property, this property is that you need to understand the first property. If I will say this is the first property and this is the second property, to understand that, we need to understand the first one. For example, we have 4 raised to 1, that is 4. If and only if we have definition says logarithm of 1 is equal to logarithm of 4 raised to 1 with a base 4. So if your exponent is 1, or your base is equal to your, for your y, this is your y, if they are equal, then you have always 1. Another example is 10 is equal to 10 raised to 1, if and only if 1 is equal to logarithm of 10 raised to 1 with a base 10. So the exponent then, the exponent there. Okay, how about this? We have, for example, 4 raised to 0 is equal to 1. If and only if 0 is a logarithm of 4 raised to 0 with a base 4. As you can see here, this is also 1. And the exponent is 0. So a logarithm of 1 in any basis, it is always equal to 0. For example, 5 raised to 0, that is also 1, if and only if 0 is equal to logarithm of 5 raised to 0 with a base 5. Okay? Let's see if we have more. This one. X is equal to b raised to logarithm of x with a base b. It should be equal. These are different. Okay. So to show you how to prove this, we need to remind us about the functions b raised to x and the inverse function, that is logarithm of of x with a base b. Okay, they are inverses. And if you studied functions, you know that f, a composite function f and its inverse, that is always equal to x. So let's try if we can prove that x is equal to b raised to logarithm of x with the base b. Okay, so if I'm going to put it here now, logarithm of x with the base b, that is this one, that one, is equal to b, we have here, that one, raised to logarithm of x with the base b. And this one is this up here, the exponent here is the value of your x there. See, this is also x. Okay, so if, according to the property of inverses, composite function of inverses, this should be equal to x. Therefore, we can say that x is equal to b logarithm of x with the base b. So for example, we have 13, for example, we have 13. That is just telling us that we have b raised to logarithm of 13 with the base b. They are equal. So you can change the bases. 13 is equal to 10 raised to logarithm of 13 with the base 10. They are equal. It doesn't matter what is the base. That's the application of this. Okay, let's see if we can apply that. Find x if logarithm of x is equal to 3. Then we have, if we apply what we have learned, that they are equal, this one, that means our logarithm of x can be expressed 10 raised to logarithm of x is equal to 10 raised to 3. And this one is, if I'm going to write it here, b raised to logarithm of x with the base b. They are equal. So if we have this means that we have x is equal to 10 raised to logarithm of x with the base 10, as we have here. So that means this is now x is equal to 1000. You can check, because logarithm of 1000, as you know now, is 3. The other one is 10 raised to logarithm of x. Is approximately 10 raised to negative 0.271. Then you can use your calculator. X is approximately 10 raised to negative 0.271. That's basically how to apply the first property, or the third property. What I want to note here is that when you solve an equation, if it's, for example, b raised to x is equal to a, then you need to have logarithm. Solve this by logarithm. I will show you later. And then if you have log of x is equal to a, then you need to use this by exponential. That is what I use here. I use the exponential with the base 10. Base 10 is the easiest. But later, we will discuss also natural logarithm, then you can use base E also. Okay, I will stay there. I will stop there. On my next video, I will be discussing more examples on the 4 properties that I discussed. I discussed 4 properties already. Then we will see how we can use it on my next video. See you around.